got some graphs here. If we have a line, think about that for a second. It doesn't matter what 2 points I choose. If I were to come up with the slope between any 2 points on a line, it's gonna be exactly the same, okay? But I need you to think about this. I've got some various graphs here that are funky curves, right? If I ask you to figure out what the slope is between these 2 points, that slope is going to be very different than if I ask you to figure out what the slope is between these 2 points. Like to the point where this slope is clearly something positive, this slope is clearly something negative. If I ask for the slope of between these 2 points, we're going to have a positive slope, right? If I ask for the slope between this point here, the purple one, and this one, what changes with the slope there? The slope would get a lot more steep. It would be a lot higher, a lot stronger then. So if we are looking at various graphs, and I've just kind of put a few different examples here, think about different places we could put points and how the slope between those 2 points could be different at between any of those 2 points, right? So that's what we're looking at here, is what's referred to as average rate of change. So we use that term to refer to the fact that we are talking about curves rather than lines. Okay, so that's the key thing to realize. Okay, so average rate of change, or AROC, if you notice what it says here, it says in algebra, guys, we've looked at stuff that's linear now, right? You've learned that the slope between any 2 points on the graph of a linear function has a constant rate of change. Our slope is the same on any two, regardless of any 2 points we choose on a line, our slope will always be the same, right? Okay, if we have a function that is not linear, so it could be a parabola, it could be some other type of funky curve, and I'm going to show you a few here in just a second. So if it's something that's not linear, you've got to think about the fact that our slope is changing between any 2 different pairs of points that we are looking at. So I'm going to show you some examples of that in a second. So we can't talk about it being a constant rate of change. We have to, but if we're going to find a rate of change, what we're going to have to do is find an average. Okay? So keep that in mind. I want you to kind of think about this visually. So back to our notes. We're going to use the term average rate of change to refer to, we're still going to find the formula that we're going to use, that I'm going to write out for you here. We're still using the slope formula. Only now we're finding the slope between 2 points of graphs that are not lines. So we just have to change a little bit of wording, but we're still going to do the same process. Okay? So technically here, the algebraic way of writing AROC, or the average rate of change, is that we say we take the y value for the second term minus the y value for the first term, and then we divide it by, we're looking at a ratio, a rate, so we're looking at numerator over denominator. Then we divide it by the difference between the second minus the first term. Guys, what does that sound like? What is that really? That's our slope formula. So y2 minus y1 over x2 minus x1, or however you want to write your slope formula. So here's what I want you to think about. AROC is the term we use when we are looking at functions other than lines. Functions other than lines. We can't say we're finding the slope, because the slope would imply that we are looking at something that is constant. So we've got a different word that we're using to basically say we're talking about the same thing, okay? So I think some people kind of get confused because it's like, we're doing slope. Why are we're finding the slope? But because we're talking about different intervals on a particular graph that's not a line, we can't really use that term. Okay, here's the other thing. You're going to see that there are different formats that are used for writing and explaining and saying to do the same process. Okay, so I think I kind of shared a few different ways that it can be written. And I'll try to kind of write it out in some of the examples that I do as well here in just a second. All right, so here's what I need you to realize. Here's the other part of this, is that we don't know what the values are, so we're going to have to plug in and figure out what they are. So notice what it's saying. It's saying find the average rate of change for this particular graph. We don't even have to know what the graph looks like. We can think about what it would look like. It's negative and it's something x squared. So we know it's a parabola and it's opening up or down?
Down.
Down. Okay. So you can kind of visualize we have a parabola. There's definitely a shift to it, right? It's not right at the origin, and it's pointing down. Okay? So it looks something like this. And now it's asking and saying, find what the average rate of change is, or our slope, in these different intervals. Okay? So what that tells us that we are going to have to do is we're going to think of this first point as x or y, and then y, or we can call it a and b if we want to think about kind of this notation here. I'd rather think about it as a and b rather than x and y, because really this is two x values. Okay, this is saying we want to plug in a is equal to -3 into this equation. So if we plug a equals -3 into that function, then we get -2 times -3 squared plus 6. So -3 squared is 9 times -2, so -18 minus 12 plus 6. So -30 plus 6, so -24. Okay, so we have one point, which is -3, -24. Okay, so we've plugged in the first point, and now we want to plug in that second point. So I'm going to call that point B, and we're going to plug in -1 into that equation as well. So -2 times -1 squared Okay, -1 squared is 1 times -2 minus 4 plus 6. We get 0. Okay, so for our second point, we get -1, 0. So think about where these values came from. This is telling us our first x and then our second x, right? That's what those numbers are. We plugged in to come up with what our corresponding y values are. And now we're going to go through the process of doing AROC, or average rate of change. So we're just going to plug in and do our slope formula. So let's do that. So we want to do, we want to do -24 minus 0 all over -3 minus a -1. So we get -24 all over -2. We get positive 12.
Wouldn't it be -1 minus -3?
I did -24 minus 0. So I want to do -3 minus -1. I want to make sure I'm sticking with the same order.
Okay.
Does that make sense?
Yeah.
Okay. So our average rate of change for this interval from -3 to -1 on the graph is 12. Okay. All right. I'm going to label this a little bit differently for this second one. I labeled it as an A and a B. Let's label this, what's really happening here, this is my first x, and this is my second x, right? So if x is equal to 2, we're going to plug in and figure out what we get for our answer. And then if x is equal to 5, we're going to plug in and get our answer. Come up with our 2 points. So let's do that. So if x is 2, let's see here. What do we get? 2 squared is 4, times negative 2 is negative 8, plus 8 plus 6. So we get 6. So our first point is 2, 6. I went through that quickly. Take a look at that. Make sure you follow how I got that. And then similar process, I'm plugging in x is 5. So negative 2 times 5 squared plus 4 times 5 plus 6. 5 squared is 25 times negative 2 is negative 50 plus 20 plus 6. Negative 30 plus, negative 24. So our second point is 5 comma negative 24. Go. Yep. Okay. And now we are going to do AROC. In other words, plug into your slope formula. So your pick in terms of the order that we're going to do this. 6 minus a negative 24 all over 2 minus 5. If you want the other direction, that'll work also. What does that give us?
So you can do it either direction and you still get the same.
Either direction, just like you do with any other slope that you're doing. But yes, exactly. So what do we get here? We get negative 10. Okay, think about this for a second, guys. Between negative 3 and negative 1, obviously the slope of this graph, it's going up, right? It's increasing. It's a positive 12 is our slope. Now between positive 2 and positive 5, it's going down, right? And it's pretty steep there also. All right, I want you guys to try the last one. Work with your next door neighbor, work with your partners. However, some people like the A and the B, some people like the X1 and the X2. You do what makes you comfortable.
Yeah. Sorry, I'm not done.
Oh, sorry.
I have to redo it, but you go.
Okay,
Take a minute.
you're negative 2, negative 10, that looks good.
Yeah, I'm just not done.
And what's the other point? You plug in 3 and what'd you get?
Oh, I
You haven't gotten there yet?
No.
Okay. All right, did everybody get 2? Positive 2, yes? Okay, Saoirse, let me know there if you need me to.
Okay. No,
Okay.
I get it.
Rita?
I get it now.
Okay. It's so easy to make silly mistakes with signs. Okay. Wording's different, means the exact same thing though. So if you flip over to that next page, take a look at how these are worded. It's just worded differently, but you're going to do the exact same process. So we are not going to work through all of these. I'm going to work through one more with you, and then I'm going to ask you guys to try a couple others, okay? So formula for distance traveled by falling objects on the moon is given by that particular formula. D of t is the distance in feet, t is the time in seconds. Find and interpret the average speed of the object for the time interval, right? So from 1 to 2 seconds and from 2 to 3 seconds. So in other words, we're going to say x is equal to 1 and x is equal to 2, and we're going to plug in and figure out what the corresponding y values are. You did get 2?
Yeah.
Good. Okay. All right. If we plug in x equals 1 into that equation, 1 squared is just 1. We multiply by 2.7, we get 2.7, right? If we multiply 2, if we plug in 2, we get 2 squared, which is 4. We multiply by 2.7, we get 10.8. And now we're supposed to do AROC. So we're doing 10.8 minus 2.7 all over 2 minus 1, which is just 1, right?
So it's 8.1.
So we get 8.1 there. don't we? Okay.
So you plug in the second. So you plug in 1. So 1 squared.
Now let's do similar thing on this one. Think about what that's saying. We're doing x equals 2. Figure out your corresponding y. X equals 3. Figure out your corresponding y. And then let's plug into formula. So try that real quick. Let's go over that one. And then I'm going to ask you to try a couple more here. Okay, so what do we get for y when we plug in x equals 3? 24.3, yes. Okay, and then we are doing AROC. So we're doing 24.3 minus 10.8 all over 3 minus 2, or just 1. What does that give us? 13.5. Right? Okay. I would like for you to try these two yourselves. Talk with your neighbors. Try those real quick. We'll go over answers in just a second. All right, what we get here, you should have -6 for the AROC there and -2 for that one. If you guys tried that last one, it should be -7. Should we go through with any of those? Positive and negative signs that you have to just be so careful with, right? Your points here should be 2, -3, and 4, -15. And your points here are -1, 9, and 3, 1. How'd we do? Okay. Your homework gives you more practice with linear equation type stuff, but it also gives you some practice with AROC, okay? It's a different assignment. Some of the page numbers are the same, so don't think that it's the same assignment. It is a different assignment than the one that you did last night for today, okay? You're doing some from pages 213 and 214. You're doing some from pages 226 as well, okay?
Are we done?
Is that it?
We are done.
Okay.